If humans are living on the moon in the year 2200, there's one resource that decides everything. Water, not gold, not rare metals. Water. Because on the moon, water is not just something you drink. Water is air. Water is fuel. Water is farming. Water is survival. So where does the moon actually get it? The first and biggest source is the moon's poles. Near the North and South poles, there are craters that never see sunlight. They are permanently shadowed and unbelievably cold. For billions of years, tiny bits of ice have collected there, delivered by comets, trapped by cold, protected from the sun. By 2200, these polar craters are not scientific mysteries. They are industrial sites. Picture a mining zone built on the edge of eternal darkness. Robots crawling down into shadow, heated drills loosening frozen regolith, and sealed transport containers carrying ice back to processing hubs. But polar ice won't be the only source. Source 2, recycled water. On the moon, nothing gets wasted. Every breath you exhale contains moisture. Every drop from cooking, washing, and even sweat is captured, filtered, and recycled. In a mature lunar city, water loss is tiny, a closed loop. Source 3, oxygen-rich minerals. The moon's soil is loaded with oxygen chemically locked into minerals. By 2200, industries will extract oxygen from regolith at scale. That process also creates byproducts that can feed water production systems, especially when combined with imported hydrogen. Which brings us to a final source, hydrogen shipments. Hydrogen is light, valuable, and portable. A lunar economy might import hydrogen and combine it with oxygen extracted from the moon to make water, like manufacturing rivers. So by 2200, the moon gets water from polar ice mining, near-perfect recycling, regolith chemistry, and selective hydrogen imports. But the next question is bigger. What will lunar water actually be used for? That's where it gets wild. On Earth, water is mostly water. On the moon in 2020, water is a multi-purpose technology. First, drinking and living. Lunar cities will run on closed-loop life support. Water is filtered and reused again and again. Bathrooms, kitchens, humidity control, all designed to lose almost nothing. Second, oxygen and air. Split water into hydrogen and oxygen, and suddenly you've made breathable oxygen. Oxygen is the currency of survival in space, so lunar water is basically bottled atmosphere. Third, rocket fuel. This is the biggest industrial use. When you split water, you get hydrogen and oxygen, and those two together make one of the most powerful clean rocket propellants. In 2200, the moon will be a launch platform. Low gravity means it's cheaper to leave the moon than Earth. So lunar water becomes fuel for cargo ships, crew transports, deep space missions, and asteroid mining fleets. You won't just drink lunar water, you'll launch it. Fourth, farming. Plants need water, but they also need stability. Lunar farms will be inside sealed domes or underground caverns with hydroponics and aeroponics. Water cycles through roots, gets cleaned, and returns again. A single liter might feed a crop system for months. Fifth, radiation protection. Here's the part most people don't expect. Water is actually a great radiation shield. By 2200, lunar habitats may use water walls, thick layers of water stored in tanks around living spaces. It protects people while also being a reserve supply. Finally, thermal control and industry. Water can store heat. Lunar bases will use water loops to carry heat away from machines, balance temperature between day and night, and keep habitats stable. So the moon's water in 2200 will be a life supply, an air factory, a fuel refinery, a farm system, a radiation shield, and a thermal battery. That's why the real story of the moon isn't just colonizing a rock. It's building an economy around water, in the driest place humans have ever tried to live.